Welcome to today's lesson. In this tutorial, we will rewrite simple trinomials into factored form and identify factors of quadratic functions given a graph. We are reviewing our factor skills from Algebra 1, and today we're going to be focused on simple quadratics, simple factoring. That means that A is going to be equal to 1 today. Before we begin, I'd like to review some vocabulary that will help us in today's lesson. The word factor, I'm first going to be using it as a verb, which means it's an action, something to do. Factor means to rewrite as a product. For example, if I wanted to factor the number 21, I would rewrite that as a product of two of the numbers that multiply to give 21. For example, 3 times 7. I have now factored 21. Factor as a noun, in the end, once you've factored, the two numbers or two expressions that we'll have are called factors. 3 and 7 are factors of 21. So I'll be using it as a verb, and we shall use it as a noun. Greatest common factor, GCF, that's what GCF stands for. This is the first thing we should always look for when we're factoring. You should always look at your terms and see if there's any common factors that we can pull out first. And that's where we're actually going to start today's lesson. Always look for a GCF first. Lastly, I'd like to make sure you understand the difference between an expression and an equation. An expression does not have an equal sign. The first three examples here are all expressions because they do not have an equal sign. All you can do with an expression is just rewrite. We'll just rewrite it into some other form, in factored form today. If we have an equation, that's when we do have an equal sign, and that's when we will be solving for answers in the end. So please understand the difference. An expression, we're just simply going to rewrite it into another form. An equation, of course, we note it by an equal sign. We will be solving for answers in the end. So let's look at our first examples. We are doing some GCF examples first. I'm looking at this binomial. Binomial has two terms. I see that both terms have an even number in them, so I know that 2 is going to be in my GCF. I also see that they both share an x. So I'm going to pull out a 2 and an x together as 2x. Once I pull that out, I'm going to write a set of parentheses for everything else that remains. Now, what I mean by pull it out, I mean divide each term by that GCF. I'm going to divide each term by 2x and pull that out of my expression, and inside my parentheses will be what remains. So if I take the 2 and divide the 2 out, well, obviously there's only a 1 left. If I have an x squared, which represents two factors of x, and I take one of them outside the parenthesis, then one of them will remain inside the parenthesis. Then, of course, I have my plus sign. If I have this 6 and I divide that by 2, that must mean that the factor of 3 will remain. And if I had the factor of x but I took it outside, then it no longer is inside. And this is factoring using a GCF. I find what's common and I pull it outside, and leaving one set of parentheses with everything else that remains. Now, if you want to check yourself, just understand that what you just did is you undistributed this problem, and distribution should put it back to the beginning. So 2x times x gives you your 2x squared, and 2x times 3 gives you your 6x. So you can always distribute to make sure that you have the correct answer. Looking at number 2, I see my numbers, and the first thing that pops out to me is that they are all divisible by 5. I'm going to pull out a 5. I see 3 factors of x, I see 2 factors of x, I see 1 factor of x. The most then that are in common is this 1 factor of x. It has to be common to all of them. So I'm going to pull out a 5x, and I think that's it. So if I pull out a 5x, and if you want to divide each term by that 5x, I think that that's visually helpful. Pull out your little arrows. Let's see what's left. If I pull out a 5x from 3 different things, I should have 3 different things in the end. 5 divided by 5 gives me a 1. X cubed divided by x would leave 2 x's left, so x squared. Take the minus sign. 10 divided by 5 is 2. I had two factors of x. I took one of them out, so there's still one factor inside. Then my plus sign. 5 divided by 5 is 1. X divided by x is 1. So 5x divided by 5x is 1. There still has to be something here. Now let's not box this in because I'm actually going to come back to this problem to complete it. It's actually not finished, but we'll do that in a minute. Example 3, I'm looking at my numbers first, and I see that they're all divisible by 3. But this time I'm not going to pull out a 3. I'm going to pull out a negative 3. And I note that because it's actually starting with a negative. And if my problem starts with a negative, I'm going to use the negative in the GCF. I do not see anything else common. This term does not have a variable. So this time there is no common variable. It's just the negative 3. So I'm going to pull out the negative 3, and I'll be left with 3 things in my parentheses. If you'd like to put the little negative 3 underneath each of these, I think that that might be helpful. Watch out when you're pulling out a negative because that will change all of the signs. A negative term divided by a negative turns this to a positive, and it would be x squared. Negative 15x divided by negative 3 makes this a positive 5x. And a negative 18 divided by a negative 3 makes a positive 6. Again, don't box this in because I'm going to come back and finish this problem too. So that is factoring by a GCF. And remember, you should always be looking for a GCF first. Always train yourself to look for a common factor in all of your terms first. Now let's look at some trial and error. These are trinomials, and when it's a trinomial, I use trial and error. Now implied with that is the error part. We might make a few mistakes along the way, and that's what erasers are for. But I like trial and error because it gives me a better sense of my factors and the numbers that are resulting in these trinomials. So here's a trinomial, and this is a result of multiplying two binomial factors together. That's that FOIL, FOIL method that we've done before. So what I like to do is understand that if the FOIL method resulted in this first term, then I just need to figure out what makes this first term using a product. Well, today, because a is equal to 1, it's pretty simple. There's only one option, x times x. So I know if I can factor this trinomial that the very front of my parentheses must be x and x. That's pretty simple today. The back of the parentheses, that results in the last term of your FOIL, and that is going to be 6. Now there's two options to get 6, 1 times 6 and 2 times 3. Now I need to figure out which of these options this is going to be. Before I do that, I want to note one other thing, and it's this sign right here. And this is a pretty powerful sign when you're factoring. If you have a positive 6 and you're going to be multiplying two numbers together to get positive 6, I hope you understand that the numbers have to have the same signs. A positive 2 times a positive 3 results in positive 6. A negative 2 times a negative 3 results also in positive 6. So if this is a plus sign in your trinomial, both factors have the same sign. They either both have to be positives or they both have to be negatives. They can't be one of each because then if one of them is positive and one of them is negative, this would be a negative 6, and it's not that. So if they have the same sign, then you can look at this sign to see what they are, and they're both going to be minus signs. They both have to be the same, and they both have to be minus signs. So I know that they're minus signs. So now I have to figure out what's going to be the back numbers. Is it going to be a negative 1 and a negative 6, or is it going to be a negative 2 and a negative 3? Well, that's where this other number comes in, the middle term, that negative 5x. Now I know that it must be a negative 2 and a negative 3 because when I check this, as you always should, the inner terms make a negative 2x, the outer terms make a negative 3x, and when I add those like terms together, I get my negative 5x. So there we go. That's always our checking tool right there in the middle. I know how to multiply to get x squared. I know how to multiply to get 6. I understand this about my signs. Then it's all about which of these factors will add together to make my negative 5. And it's negative 2 and negative 3. And we factored it. Let's look at our second one. I've got x squared minus 13xy minus 30y squared. Now don't worry that we have multiple variables in here. It's the same exact setup. I'm going to break apart my first term. In this case, it's only x times x. That's kind of helpful. I'm going to write my parentheses, and I know that the fronts have to be x times x. The second part, I have to split up 30y squared. Oh boy, there are a couple different options for that. I'm going to start with 1y times 30y, and then 2y times 15y, and then 3y times 10y. 4 does not go into 30, but 5y times 6y. Okay, so we have 4 pairs that multiply to give 30 and the y squared. So the question is, which of those is going to be the correct one? Well, one thing I want to talk about before we do that is that this sign is negative. If you're going to multiply two things together to get a negative, then you know that the factors have different signs. They cannot both be the same this time, because if we need to result in a negative, one of them has to be negative, the other one has to be positive. So I can put a positive sign in one and a negative sign in the other. I know that that has to be true. And since now I know that I'm subtracting numbers to get to this negative 13, my eyes are on this one right here. I know that 15 minus 2 is 13, but actually I need negative 13. So I think I need to go that way, 2 minus 15. So the 2 is going to have to be positive, 2y, and the 15y has to be negative. We should always check ourselves to make sure that we're correct. If I multiply the inner terms, I get 2xy. If I multiply the outer terms, I get negative 15 xy, and when I add those like terms together, I do get my negative 13xy, which is exactly what I needed here in the middle, so I know that I'm correct. Now that we've factored a couple trinomials, let's go back to example 2 and example 3 because we are not actually finished. We have a trinomial here. Once you factor out a GCF, that doesn't mean that you're necessarily finished. What's left might factor more. So I'm going to try and do that. I know that x times x gives me the x squared. 1 times 1 is the only option to multiply to get 1. And I know that my signs are the same. So this 5x will always still be here. It doesn't disappear for some reason. The GCF will always just be outside. It'll be the first thing that you write down. The x and the x will be the front of the parentheses. The 1 and the 1 will be the back of the parentheses. I know that I have the same sign, and now I know that they both have to be negative. If I check that, I see a negative x and another negative x. That makes my negative 2x. Perfect. Now I also notice one more thing. If my factors are exactly the same, I could be a little bit fancier and use my squared symbol. Since they're both exactly the same factors, I could write them as a quantity squared. That's the best looking answer. You could write it like this if you want to, but we could be fancy and put our squared symbol there too. And let's look at our last one here. Inside the parentheses looks like a trinomial that can be factored. X times x to get x squared. 6 could be 1 times 6 and 2 times 3. I know that my signs are the same. And if they're the same, then that means I'm adding together. And to get a 5, it's 2 plus 3. So the negative 3 is going to be right here. Again, the GCF is always the first thing that I write down. Then I'll put my parentheses. I know I've got the x's in the front. I'm going to choose the 2 and the 3 because those add up to be 5. And I know that they're the same signs, and this is the sign that they both must be, pluses. And now I factored that one. Okay, now that we've factored many expressions, let's start solving some equations. So we're going to be solving our equations and we're going to be looking for the roots. Now, of course, when I say roots, I really mean any one of four words that we've been learning. Roots or zeros or solutions or x-intercepts. All of these mean exactly the same thing. Find the solutions. Now, to find our solutions, we're going to be using what's called the zero product property. And that states that if we have multiple things that multiply together to equal to zero, here's our zero, here's our product, the property says that each one of these could be equal to zero. If you're multiplying a bunch of different numbers together and the product is equal to zero, then you know one of them has to be equal to zero, or two of them could be equal to zero, or all three of them could be equal to zero. So this is very helpful. If you can factor the left side of an equation and the right side is equal to zero, each one of your factors could be set equal to zero to solve your equation. So let's start with example 6, which is the easiest example that I could give you because I've already factored things for you. There are two factors that are multiplied together and they're set equal to 0. So that means that each one of these could be set equal to 0 individually. X plus 2 could equal 0. 3x minus 1 could equal to 0. And those are our two little equations to solve for our answers. All we have to do is subtract 2, and we know one of our answers is negative 2. We have to add 1 and divide by 3, and we see that our other answer is positive 1/3. Now there's a fun little trick that you can do so that you don't have to show this math every time. Remember, it's always going to be the opposite of the symbol that you see in your parentheses. If you see a factor x plus 2, your root will be negative. If you see a factor that has a minus sign in it, your root will be positive. But even better, watch this. This is going to turn to a positive, and then it's always this number divided by this number. So there's where the positive 1/3 comes in. And here's our negative 2 divided by 1, which is just negative 2. So this has already been factored, so that's pretty easy to do. This one is a little bit more involved because one, I don't even see it equal to 0 yet. And of course it's not factored. So we must have it equal to 0. So let's subtract the 36. That should be your first move. Set it equal to 0. That's the most important part to be able to use the zero product property. Now we need a product. That means that we need to factor this trinomial. Well, let's go back into doing our trial and error. I know that x times x can get the x squared. 36, oh boy, let's see what we've got. I like to go in order so I don't forget anything. I'm going to start with 1. 1 times 36, I'll go to 2. 2 times 18, I'll go to 3. 3 times 12. If you have trouble figuring out what multiplies to get 36, just take 36, plug it into your calculator, divide by 2, divide by 3, divide by 4, divide by 5. You'll see that 1, 2, 3, and 4 divide evenly. When you try to divide by 5, it doesn't work. It gives you a decimal. So 4 times 9 works, and then 6, of course, times 6. Yikes, we've got 5 pairs that can multiply to give 36. So I'm going to write my sets of parentheses. I know that it's going to do that. I also know that it's equal to 0, so it's going to remain equal to 0. Please do not forget that it's an equation here. I know that the fronts have to be x times x, and let's see if we can figure out what the backs are going to be. I do know that the signs are going to be different. They're going to alternate. One's positive, one's negative. And that means that I'm going to be subtracting these numbers to get negative 5. Well, that leads me to think that it's going to be the 4 and the 9. If I do 9 minus 4, I get positive 5. If I do 4 minus 9, I get negative 5. So it must be a positive 4 and a negative 9. And that will work. You can check yourself. Here's a positive 4x, and here's a negative 9x. That multiplies, excuse me, that adds to give negative 5x. I'm not finished once I have my factors. This is just very helpful to use my zero product property. Now let's figure out what my answers are. So this x is going to yield a negative 4 That's the number that would make this parenthesis 0, -4 plus 4. And this value of x would be a positive 9, because 9 minus 9 would equal to 0. I'm just going to write them side by side, and I'll be finished. So that's solving using our zero product property. Understand that these are equations because they have equal signs, so our answers are going to be equations solving for our values of x. Now let's solve these equations that have been graphed. The state test is going to use this word apparent. Find the apparent factors from the graph. Well, it's really easy to find the roots because there they are. This root is a -1, and this root is 1, 2, 3, 4, 5. So it's really easy to find the roots or the solutions. Can you convert them back into factored form? Well, I hope so. It's not really that difficult. You just need to understand that it's going to be the opposite of your value. If you see a -1, the factor is going to be x plus 1. I'll put a comma. If you see a positive 5, the factor will be x minus 5. And that's it. Those are my two factors. Find the root and then convert it to a factor. Let's just take that opposite idea. Let's do the last one. This is the value of -4. This is the value of -2. Convert those into factors and you'll have x plus 4 and x plus 2. I'll put them side by side without the comma this time. It doesn't really matter. Just understand that we're not writing the equation of this graph. We're just finding the two factors from these roots. If we wanted to write the equation, we'd have to go and find what a is. Clearly a is a negative in this one, and this one, it looks like a is probably a positive 1/2. But we're not writing equations, we're just finding the factors given the roots in our graph. Thanks for watching this tutorial. I hope you had fun, and we'll practice this more in class. Thank you. Yeah. See ya.